Experiences are what people love the most about travel. Viator is a website and app where you can book travel experiences like hiking Mount Kilimanjaro in Tanzania or enjoying the views while cruising on a catamaran in the Caribbean. They offer everything from simple tours to extreme adventures. With over 300,000 bookable experiences in 190 countries, there's something for everyone. Plus, Viator's travel experiences have millions of real traveler reviews, so you have the information you need to book the best activities for your trip. When you book a travel experience with Viator, there's always flexibility and support with free cancellation, payment options, and 24/7 service. Download the Viator app now and use code Viator10. That's Viator 10 for 10% off your first booking in the app. One app, over 300,000 travel experiences you'll remember. Do more with Viator.
With Starbucks Holiday Blend for Nespresso Virtuo, now exclusively at Target, there are even more ways to share the joy. Savor every smooth and festive sip all holiday season with friends and family at home to fill every indulgent day with cheer.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello, how are you? Nice to have your company here on the Space Nuts podcast, episode 259. My name is Andrew Dunkley, and with me, as usual, is the one and only Fred Watson, astronomer at large. Hello, Fred.
Ta-da! Hi, Andrew. How are you doing? Still here, still at large.
Well, actually, rather than a ta-da, I can do this. There you are.
Very
Welcome,
good.
Fred.
Thank you. It's nice to have a drum roll.
Something different. Now, coming up in this episode, we are going to announce a little bit of good news, something that might have slipped under the radar a bit, but we're going to talk about it. Speaking of not slipping under the radar, Unidentified Aerial Phenomena, the Pentagon's released its report into these incredible sightings that somebody asked us about a few weeks ago, and we gave our personal opinions of them. Well, now there are official opinions of them, so we'll talk about that. It's quite an unusual story, as you'd be aware, but have they got answers? Well, no. We're also going to look at 2,000 stars, all of them individually, one at a time, today, and these are stars where if there are intelligent beings, they could probably see us. Hi! And we'll answer some questions. Actually, we're going to revisit something we talked about last week. We for the cover of our episode 258 podcast, we put up a photo taken by airline pilot Mark Snelson of Noctilucent Clouds, and I did suggest that in the photos you could see the curvature of the Earth, and Fred, put that one to bed. Well, Mark's actually challenging that, so we're going to revisit it. And we've also got 5,000 questions from Ashley in the United States. It's one massive question broken down into 5 parts. Plus, he's got an idea for something we should put in the Space Nuts shop. So we'll investigate that as well. But first, Fred, I wanted to let you know I'm stuck at home at the moment because Sydney's had a bit of a COVID outbreak and basically has been locked down. So I assume you're stuck at home. I'm stuck at home too, even though I don't live in Sydney, because I was there on the date of the cutoff of the COVID lockdown. So even though I'm now home, I have to lock down as well. So I'm doing my radio show from home. I'm doing the podcast from home. I'm doing my other job from home with the Salvation Army. It's just, like we're back to where we were over a year ago. It just feels so strange.
Let me just put that in context, Andrew, because yesterday I had an email from a friend and colleague, very famous astronomer, Brian Gensler, who's the director of the David Dunlap Institute in Toronto. And he told me that they have just come out of 7 months of lockdown in Toronto. And he was saying he's been working from home since March 2020. He hasn't been into the office at all. So we're doing pretty well. We've got a fortnight of lockdown. I can put up with that.
Yeah, we are. My two boys in Sydney, Fred, have been working from home for over a year.
Yeah.
They were just starting to go back into the office a couple of days a week, and now back to working from home. It is so fortunate that they've got jobs where they're able to do that, though. So many people have lost their jobs, and it's been very, very hard on some individuals. So certainly not counting our, not dismissing that. It's a pretty serious situation. But we once again ran out of toilet paper. What is it? I don't understand what's going on with that. But anyway,
I don't get that
that's
either.
the situation. I'll be here. I'll be here till early next week, and then unless things change, I should be able to get back out into some sort of normality. So it's not a massive lockdown. This one, fingers crossed. Just depends on how the numbers go, I suppose, in Sydney in terms of infection rate. But yeah, it just shows you how nasty this Delta variant is. The way it's been described as being able to spread fleetingly, and I think they actually got on film two people walking past each other.
Yeah.
One infected the other, and they weren't even within 1.5 meters of each other, which is just extraordinary and terrifying all at the same time. Now, Fred, let's move on. You've got some good news about the Square Kilometer Array.
Indeed, I have. Yes, a couple of days ago, in fact, yesterday actually, the 29th of June, 2021, the SKA Observatory announced that it had officially approved the start of telescope construction in Australia and South Africa and outlined its 10-year funding schedule. So remember, the SKA is what will be the world's biggest telescope. The mid-frequency dishes will be in South Africa. The low-frequency antennas, which look like Christmas trees, are in Western Australia. But there are many countries involved. At the moment, there are 7 nations that are the current members of the SKA Observatory, but a further 9 countries are expecting to participate. And on-the-ground construction here in Australia is expected to begin early next year. So it's big news. I'm going to illustrate it as well,
it is.
Andrew, for anyone who happens to be watching us on YouTube, because I'm holding up a Lego SKA antenna that was given to me by the then director of the project, Brian Boyle, it's probably 10 years ago. Now, the final thing doesn't look anything like this Lego antenna, but it does say on it, I think it says SKA on it somewhere. Indeed, it does, SKA, and that's what it was meant to be. Isn't it, Dink?
There you are.
A Lego antenna. Everybody should have one.
It is. Oh, and it moves. But as you say, they've redesigned them. They won't look like that now.
No, not even the mid-frequency dishes in South Africa look like that. They are a different design altogether from this, but they are dishes, whereas the ones in Australia are Christmas trees. 131,000
antennae. Yeah, it's extraordinary, isn't it? Yeah,
it's amazing.
Well, that's great news, and it'll be a slow burn in terms of the project being finalised, but it'll be worth it when we are able to solve all the mysteries of the universe in 5 seconds once they switch it on.
Yeah, that's right. That'll be it.
Yeah. Right, let's move on to this other fascinating story, which has received so much traction in the media, and I think it is worth talking about again, the Unidentified Aerial Phenomenon report from the Pentagon. Now, this is to do with the sighting of 144 aerial vehicles of some kind over a period of years. And these have been spotted by civilian airline pilots and aircraft pilots and passengers and military. And it was so impossible to ignore. The Pentagon has been investigating this, and they've now released a report into it, which I suppose most of the media, and rightly so, have said, well, what are you telling us? Because you haven't actually answered the question as to what these are. But they probably can't. They don't absolutely know, do they?
They don't. There has been some really good commentary on this actually in the media. There's a few websites that have really taken I think a pretty intelligent view of what this is all about and what the US government is trying to do. So just to clarify, those 144 reports are all from US government sources. So a lot of them are military aircraft. In fact, I think a lot of them are actually Navy aircraft. Of those 144, 80 involved observation with multiple sensors. So that's interesting. Most of the reports described unidentified aerial phenomena as objects that interrupted pre-planning training or other military activity. So it's really serious stuff. This is not based on hearsay or anything like that. These are genuine observations. I was really interested to see that the report, which, by the way, is simply titled Preliminary Assessment Unidentified Aerial Phenomena. It's from the Office of the Director of National Intelligence in the USA. The report includes a section describing the difficulties with reporting this sort of thing because, normally, you can imagine a jet fighter pilot coming back saying, "You should see what I saw today." Everybody would just pour scorn on it. And there's one of the sentences I thought was very interesting. Narratives from aviators in the operational community and analysts from the military and intelligence community describe disparagement associated with observing unidentified aerial phenomena, reporting it, or attempting to discuss it with colleagues. And it's a really interesting point that they actually highlight that. Why has the name changed from UFOs to UAP? But that's a good question too, and maybe part of it is to do with what I've just said. As soon as you mention UFO, people think you've lost your marbles. Whereas, but a more, perhaps a more serious aspect is that some of these things are not necessarily objects. The unidentified flying objects could be other things, and that leads me to the classifications that the report actually goes into. 5 different classes of UAPs, unidentified aerial phenomena, starting with airborne clutter, as they call it. These objects include birds, balloons, recreational unmanned aerial vehicles, or airborne debris, like plastic bags that model a scene and affect an operator's ability to identify true targets, such as enemy aircraft. In fact, they've only highlighted one that has been proved as that sort of airborne clutter, and it was a deflating weather balloon that they mentioned in the report. So that's the first classification. Second is natural atmospheric phenomena. Includes ice crystals, moisture, thermal fluctuations that may register on some infrared and radar systems. Interesting stuff. Then there is US government or industry developmental programs. Some UAP observations could be attributable to developments and classified programs by US entities. We were unable to confirm, however, that these systems accounted for any of the UAP reports we collected. So, they've asked around, are you doing anything top secret? No.
Oh, no, nothing to see here.
Nothing like that. And then classification 4 is really interesting. Foreign adversary systems. Some UAP may be technologies deployed by China, Russia, another nation, or a non-governmental entity. However, later in the report, they kind of play that down because and it's certainly true. If there were these things that were capable of Mach 500 acceleration, 500G acceleration, I beg your pardon, and very high speeds, well above the speed of sound. They also there are reports of things that travel faster than the speed of sound without leaving a sonic boom. That sort of technology takes decades to develop, and there is nothing in the intelligence community that suggests that any other nation is doing this. And they also say, and even if they were, why would they, whiz it around military training places, which is where a lot of these things have occurred and been seen. That could just be a coincidence, but it's more likely to be the fact that around military training bases there's lots of air traffic movement, and that gives rise to lots of reports. So a really interesting idea. And then finally, the final classification is other. Although, and what they say is, although most of the UAP described in our dataset probably remain unidentified due to limited data or challenges to collection, processing, or analysis, we may require additional scientific knowledge to successfully collect on and analyze and characterize some of them. We would group such objects in this category pending scientific advances that allow us to better understand them. The UAPTF, that's the task force, intends to focus additional analysis on the small number of cases where a UAP appeared to display unusual flight characteristics or signature management. I love that. Yeah. Signature management. Disappearing, I guess that means. So, really, a really good attempt to classify all these things, to categorize them, and a worthwhile report, something that's worth having a look at. It's very easy to find on the web, the preliminary assessment of UAPs. It is, I should mention as well, basically a redacted version of a much longer report that went to Congress, which was secret. So there is more stuff, but this is
that'll get the conspiracy theorists going.
Of course, of course. But it's probably not that much more. I mean, they've told it like it is in this, and I think it's a good thing to do.
Yeah, and like you and I discussed before, we both were of the belief, and they have pointed out that it's very, very, very unlikely that we're being visited by aliens. It's more likely to be some human creation, and it could be multiple different, as they've categorized them, could be any combination or a natural phenomenon or phenomena. My belief is that with these extraordinary craft and the maneuvers they've described, it's been made by humans, and perhaps the US military itself has developed some kind of technology that they haven't let out of the bag, not even to their own people yet. I think that's very possible. But it could be a foreign entity, which is also somewhat disturbing. But look, we'll have to wait and see. They can't keep it hidden forever, would be my feeling on it. But who knows, really? Who knows?
That's right. I think that's right. You're probably right. That's a fairly likely explanation, I think. We will wait and see. I mean, what's encouraging is that this task force is going to keep going with their research, and hopefully they'll find something out.
Yep. Well, fingers crossed. They've got 143 of them they haven't been able to identify.
Yes, that's right.
That in itself is staggering, and that's only in recent years. This isn't going. We're talking since this has all happened in the 2000s and beyond. So it's not something. We're not going back to the 50s. We're not going back to Roswell. This is all new.
Right. That's right. The most, in fact, most of them are recent. So the take-home points are, first of all, unidentified aerial phenomena probably lack a single explanation, which we've gone into. There are 5 categories. But they also make the point that they threaten flight safety and possibly national security. And, that's a pretty big statement to make with a public document like this. They say explaining UAP will require analytic collection and resource investment, so they want more money. That's fair enough. That's basically the bottom line. They need to continue the work, and will do. Yeah.
I suppose I'm being a little bit flippant here, but once again, the photographs of these things, even, despite the fact that we have such high resolution, high tech cameras these days, are still too fuzzy to identify anything.
Yeah.
But their speed might have something to do with that.
And the ones that we've seen, those 4 videos, I think, that were released by the Pentagon of things that can't be explained, they look fuzzy because they're I think they're infrared images, which often, because you're measuring the heat from an object, often the object itself is heating up the region around it. So they often look fuzzy. But some people have described that as an aura, which is a step too far, because it's just, it's the kind of characteristic thing that you might get with mid-range infrared detection.
All right. We watch and wait with interest and hope that some answers will be forthcoming. You're listening to the Space Nuts podcast with Andrew Dunkley and Fred Watson.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Space Nuts.
And hello to our patrons, the people that put a couple of bucks in our tin can every month to say thank you for producing the Space Nuts podcast and to enable us to keep producing the Space Nuts podcast. It's not cheap. Everything costs money, and once you start to sort of build numbers with these sorts of things, there's all of a sudden these people coming out of the woodwork saying, "Oh, we can help you." Well, yeah, and that costs money, and some of them do. We've found some good collaborators to help us out with the Space Nuts podcast in recent times, and setting up shops and getting things produced for the shop, and it's never ending. But it's good fun too, though. And if you're a patron and you're putting some money into the tin to help us out, thank you so much. We do very much value your contribution. And if you would like to become a patron, you can go to our website and click on the supporter button and find out how to contribute. It is quite inexpensive, starts at about $4.50 a month, but you can contribute whatever you want. It's up to you. spacenutspodcast.com if you would like to look into that and check out the shop while you're there. Now, Fred, we are going to look at stars now. It's got nothing to do with Hollywood as usual, but they have pinpointed a bunch of stars, a couple of thousand of them, that may well, if they have livable planets orbiting them with intelligent life, they could go, hey, look at that. That's Earth. Oh, my gosh, we can see Earth. I'm pretty sure they wouldn't say it that way, but you get my drift.
They'd probably say it in a different language for a start.
Yeah, I'd say so. Yeah.
So this story, it's a quite a nice one. I think it's come actually out of Cornell University in Ithaca, New York, led by a young lady called Lisa Kaltenegger, and with other authors as well. What these scientists have done is asked the question, exactly what you've just asked, which stars could detect the planet Earth by the fact that from their vantage point, it transits across the disk of the sun. So, putting it a different way, what it means is how many stars are there that are exactly in line with the plane of the Earth's orbit? Because it's only if you're looking pretty well along the plane of the Earth's orbit that you would see the Earth pass in front of the disk of the sun. If you're slightly too high above or slightly too far below, you don't see it. Which is actually, from our perspective here on Earth, that's one of the drawbacks of the transit method of discovering extrasolar planets. So it means you only discover a fraction of the extrasolar planets that are out there. But as you know from Andrew, from our discussions, that's been by far the most productive way of discovering them. We now know of over 4,000 extrasolar planets, of which about 3/4 have been discovered by this transit method. And what that tells you is that planets are commonplace, that probably every star has planets. And big news. So turning it the other way around now, what are the vantage points from which any aliens who happen to have existed and avoided our detection systems with their UFOs. Oh, I didn't say that. What are the vantage points from which any aliens could actually see the Earth transiting? And what they've done is they've analysed star catalogues. And in fact, the best one now is produced by the Gaia spacecraft, European Space Agency's Gaia spacecraft, which has mapped 1 billion stars. It's an astonishing project, which we've talked about on a number of occasions, because not only is it able to map the positions of the stars with breathtaking accuracy, because you can do that, you can also detect the motion of the stars with similar accuracy, because you can look at a star twice and see how it's moved in between the two occasions. It's because of this stunning, resolution of the directions that stars are lying in to within microarc seconds is putting it technically, which is a tiny angle. And because you can measure them to that precision, then you only need to wait a few years, 2 or 3 years, before you can see them having moved. And that gives you the motion of that star through space. So what these scientists have done is taken all this information and not only said what stars are in the plane, lie in the plane of the Earth's orbit now and can see the Earth or would be able to see the Earth transiting. What stars could do that have been able to do that within a period of 10,000 years, centered on now. So 5,000 years in the past, 5,000 years in the future. Because the stars move, they cross the orbital plane of the Earth, extended way out into space, but they're only in it for a short time, and so that's why they had to look at this period of not human history, but the history of the Earth, 5,000 years in the past, 5,000 years in the future. And to cut to the chase, they discovered, now where did I put the final numbers? It's about 2,000, but they're broken down. So they've chosen ones that are within it's actually about 326 light years of the Earth. That is 100 parsecs, which is the measurement unit that astronomers usually use, a parsec, which is 3.26 light years. So within 100 parsecs of Earth, 326 light years, 2,043 have the quality that within that 10,000 years I mentioned, they have this perfect viewing geometry. They look in the plane of the Earth's orbit. Now, it's interesting that you can break it down into ones that are in the right location to have been able to see Earth in the past 5,000 years, and that turns out to be 1,715. And then there's another 319, which will come into view, or they'll be able to see the Earth transiting within the next 5,000 years. Of that 2,034 stars that would be able to see the Earth transiting, how many of them are known already to have planets? Well, the answer is 7. It's not many. But of course, many of them will also have worlds orbiting them, because we know that pretty well all stars have planets around them, and we will find some of them that are suitable for life. So it's really, it's turning the question the other way around. How many stars can see us? And what it suggests is, and the reason for doing this is that these are good places to look for alien, what you might call alien civilizations, but more especially to look for planets, to look for biomarkers on those planets, and perhaps techno-signatures on the planets as well. So that is why this work has been done. It's to identify future targets for the big telescopes that are coming on stream, to really have a good look at these 2,000 stars, just to see if there's anybody there, because if there's anybody there, they will be able to see us.
Yes, that's right. It's a two-way street, isn't it? Really.
Yeah, yeah.
If they've got the intelligence and the technology as we have, we could just look at each other and wave to each other like Marvin the Martian in Looney Tunes, who just put his telescope and it'd come right down onto Bugs Bunny's head.
Yes, that's right.
But one of the candidates that's looking quite promising in the not too distant future is about 2050. This star will come into alignment. Teagarden star, and it will we'll be able to look at each other for 410 years.
That's right.
Yeah.
Exactly. The one that I think is interesting, it's down the track. There is one of the most interesting systems of planets known to orbit other stars is the TRAPPIST-1.
I knew you were going to say that.
Yeah, which has 7 planets going around it, all Earth-sized. And we've talked about this system before because they have resonances with one another, these planets. One goes around twice in the orbital period of 3 orbital periods of the other one. They've got these resonances. But it can't see Earth at the moment, the TRAPPIST-1 system. But in a year, 3,663, they'll be able to. So a couple of, 1,600 years in the future, they'll be able to see the Earth. They will know that the Earth is there.
Yes. Well, who knows what technology will be like then and what we're capable of. And it would be a really fascinating time. I think we're in a fascinating time now for good and bad reasons. But it's who knows what's around the corner. You just you never know what to expect when it comes to looking up into the ether and gathering it all in. It is truly fascinating. But I suppose it'd be easy for people to find reports on these 2,000 stars and maybe have a look at them themselves and see if they can get a wave.
Yeah, exactly. It's easy to find the research that's been done there, and it's had quite a bit of publicity as well, which is nice.
Oh yeah. Everybody loves a story like this one. Okay, maybe more on that in the future, a couple of thousand years in some cases.
Yeah. We'll let you know. Don't worry. We'll let you know.
Yeah, we will. Yeah, we'll get to that when the time comes. This is the Space Nuts podcast with Professor Fred Watson and Andrew Dunkley.
3, 2, 1.
Space Nuts.
And hello to everybody who follows us on social media, whether it's through the official Space Nuts Facebook page or maybe the Space Nuts podcast group Facebook page, which was created by listeners so they can talk to each other. Very much worth getting onto. Of course, to our viewers on YouTube, thank you for supporting us. And we're on Twitter, we're on other stuff. It's a long list, but thanks for following us. It's nice to stay in touch, and we do often get questions or comments through social media as well. It's hard to keep up because it comes from all angles, and I'm one person, and I sometimes miss things, so I apologise for that. But I'd also like to send out a big thank you, Fred, to all the people who have bought a copy and read and reviewed the Hitler Paradox. Oh. I got my first royalty check this week, and I could buy a couple of stamps now, so I'm really, really excited.
Good stuff.
I think that you probably could relate to this, but in the publishing world, by the time you write the story, you get it all made into a book form or whatever. By the time the distributor gets their cut, the publisher gets their cut, the typesetters and editors and bookshops get their discount. By the time all of that happens and you sell one book, you get about $4. So,
well, that's good. Actually,
it's a tough gig.
Yeah, it's usually about 10%, something like that. Of the
it's not much. No. It's not much. That's the way it rolls. But thank you to everyone who's bought a copy of the Hitler Paradox. And if you could do me a favour, and it's up to you totally. I wouldn't expect it. I just hope for it. Please put your reviews online because that kind of helps people. Apparently, I heard, and I won't mention the platform, but one publishing platform that I've used basically doesn't sort of even look at you twice until you've had at least 500 reviews on a book. I mean, how do you achieve that? Unless you're a bestseller. It's just,
Could have a lot of friends.
That's very true, or just make up 100 fake accounts. But no, you can't do that anymore. Not that I've ever done that. No. Let's move along. Question time, Fred. We're doing a follow-up from something we talked about last week. Mark Snelson, airline pilot, sent us some amazing photos of noctilucent clouds that he took. And I kind of said something that turned out to be horribly inaccurate, that I could see the curvature of the Earth in his photographs. And, well, you pretty well shot me down in flame. But we've got a follow-up email from Mark. He said, I just listened to episode 258. Thanks for the mention and the cover pick. I feel privileged. Now, it's just Space Nuts, Marcus. Not important. Anyway, just as a sidebar, Fred's comment, re the curvature of the Earth, has got me thinking about whether we see it in flight or not. He would, though, of course, know a lot more about camera optics than me. Since we've been flying mainly freight, few or no passengers during the pandemic, we've been flying higher because the aircraft is much lighter, often 40,000 feet or above. I do feel we can see the curvature, only just, but I do think it's discernible from the cockpit. The noctilucent flight was at either 40 or 41,000 feet. I didn't ever fly the Concorde, sadly, but this article, and he sent us a link, if you can be bothered, is quite interesting. She could fly all the way up to 68,000 feet, according to Wikipedia. Opinions seem split on the curvature thing. Anyway, thanks again. All the best, Mark. So, let's revisit it. He kind of feels he can see the curvature of the Earth from 40,000 feet, and that in the Concorde, well, yeah, maybe. How high do you have to be, I guess, is the question.
Yeah. Look, it's such an interesting topic. And thanks very much to Mark for making those comments and for sending us the link to an article about the curvature of the Earth flying on Concorde, which is pretty easy to find. It's on the Simple Flying website if people want to check it out. Let me just clarify that the images that Mark sent us, the curvature that you can see of the horizon there is definitely due to camera optics, because
it's pretty dramatic.
It's quite pretty dramatic. That's right.
Yeah.
But I'm willing to believe that at 40,000 feet, if you look carefully and discerningly out of the cockpit windows, where you've got a panoramic view, which you don't have as a passenger on these aircraft,
true,
you might well be able to detect the first signs of the curvature. As Mark says, the article about seeing curvature from Concorde up at 60,000 feet, it basically is an open question, partly because in fact, I might just quote from this, the 2 points that it makes about people often reporting to see, about 50% of the passengers reported to see the horizon curve. And the first is, but maybe the aircraft flew at just about the noticeable threshold for seeing it curve. But the second point is that the fact that the windows on Concorde were tiny, and you wouldn't actually see anything much of the horizon. So it probably from a single window you wouldn't be able to see the curvature. A nice article which is it's by Nicholas Cummins, published actually last year, just about a year ago. A very nice article that goes into it quite deeply. So I'm prepared to believe that at 60,000 feet you certainly will be able to see the curvature. Of course, the whole thing about space tourism is to send people up to 100 kilometers, which is very, very much higher. Your 60,000 feet must be in the region of, let me do the sum in my head. It's sort of 20 20-ish kilometers, 24 or something like that. But at 100 kilometers, you definitely will be able to see the curvature of the Earth, which is one of the appealing aspects of space tourism, that and the fact that you've got 3 minutes of no gravity or weightlessness.
Weightlessness, yeah.
Yeah. A personal note, I never flew on Concorde either, but I often used to find myself, this is when I was based in the UK, in a takeoff queue on a very conventional jet, usually the shuttle between London and Edinburgh. Often used to find myself behind a Concorde taking off. So you'd be waiting on the runway, and of course you've got a view of the runway if you're in the right kind of window, and it was just staggering to watch. And the noise was also staggering. It used
had a really crackly sound, didn't it?
It did when it. Yes, that's right. But it produced this horrible orange smoke. Honestly, it was orange, and it was really, really weird because there were military engines that it was using.
Yeah,
I think they had afterburners as well. I think, I can't remember. It's a long time ago, but it was always really spectacular to watch a Concorde taking off out of Heathrow. Really spectacular.
I remember when I was a kid, Fred, and I was a scout, and one of the projects they gave me once was aircraft observation, and I had to spend time in my backyard every day recording aircraft that flew over, which turned out to be quite a nightmare because we lived near a military base. So
you do.
Oh, not another one. Mirage, Windshield, Mackie. I mean, but there was one time, and during that time, Concorde had visited Australia in the 70s, and I was lying down in the backyard just watching the sky, and I saw at a high altitude a white Delta Wing aircraft heading northwest. Now, I strongly believe it was the Concorde, but anyway, that's what I noted it as. Nobody disputed it.
Yeah, that's great. No, it was magical. It was such a piece of engineering way ahead of its time.
Oh yes, and of course they're looking at bringing back the faster than sound airliners. There's a couple of companies experimenting with smaller versions of Concorde-like aircraft, so they may well make a comeback. And of course, speaking of observing the curvature of the Earth, when suborbital flight becomes normal, and we can get from Sydney to New York in 2.5 hours or whatever. You'll definitely see it.
You'll definitely see it. That's right, because suborbital flight is just a slightly different version of what I was talking about, the space tourism suborbital flight. Instead of taking off and landing in the same place, you take off and land in two different places, and we will see that. Of course, the thing that killed Concorde was the fact that it could only fly over the oceans because of the sonic boom that it produced. But the companies you've just been referring to, investigating future supersonic aircraft, they're looking at ways of mitigating the sonic boom to make it something more like a sonic thud or something like that, rather than a distinct.
And they're talking incredible speeds with these new aircraft too. And test flights already have achieved quite incredible results as far as I've heard with one or two of them. But we watch with interest. But Mark, thank you for bringing up the debate again, and it still remains debatable.
It's a great topic, and I appreciate Mark's sending in his link to the article.
Indeed. Now, let's move on to an audio question. This one comes from young Ashley, and we've heard from Ashley before. Ashley's in the United States, and Ashley's also a patron, so thank you, Ashley. And this is one question in at least 5 parts.
Hi, my name is Ashley, and I got a couple questions. So the first one is, if the Earth did not get swallowed by the sun when the sun became a supernova, would the Earth eventually stop spinning? And also, how much longer does each day get? And what planet spins the slowest? And how long is a light year in years? And when do you think people will land on Mars? And also, one of my grandparents went to your speech. It's Fred Watson. For this shop, I think you should add a Space Nuts bumper sticker that says, "I am a Space Nut."
That is a great idea, actually, and I will put that to Hugh back in the production studio and see if we can get "I am a Space Nut" stickers. I think that's a fabulous idea. It would certainly get people asking questions. What do you mean you're a space nut? Well, I know these two idiots. Anyway, go on. Now, I just in case we forget about it later, but I think Ashley said that his grandparents went and saw you speak once, Fred. So that's lovely.
Yeah, it is nice. Yeah.
Don't know where or when, but it was probably sometime during the arrival of the Mayflower. Could have been.
That was a great day. Great day.
Let's start from the top. The effect on Earth if the sun went supernova, and would the Earth stop spinning?
Okay. First, Ashley, the sun won't turn into a supernova because it's not big enough. It would need to be a bigger star to do that. So it will swell up. It'll become so big to swallow up the Earth, as you've suggested there, but it'll do it quite gently, not explosively. The end result, though, is the same. The Earth essentially does not survive that. I think it would stop spinning. Basically, it would probably turn into a soggy blob, and the spin would, probably just cause it to disintegrate. So there wouldn't be anything left to spin. That's the bottom line. Okay, how much longer does each day get? Yeah, that's a great question. And it's about 0.02 of a second per day every 100 years. So it doesn't sound like much, but if you didn't correct for it, which we do with leap seconds every now and again, what would happen would be the seasons would get out of step with the calendar. So you'd be celebrating the longest day of the year, the summer solstice, in September or something like that, which is not really very good.
We should point out that not too long ago in Earth history, people really had a lot of trouble with the calendar because they were operating on different calendars. Some of them just didn't line up with reality, and they kept running into trouble. And then they all decided, well, all right, we all need to move over to the Gregorian calendar, and we'll all be on the same page. And most did, some didn't. Russia was very slow, but Sweden really botched it because they were going to do it by deleting leap days for a period of 12 years or 12 times or something. And war broke out, so they couldn't. And they forgot to do a couple. And then at the end of the war, they went, this is all too hard. So they put all the days back. And for the only time in history, in only one country, there was a February 30th. And then they didn't do it again for another 20 odd years, and they finally got, I think it was 1758 or something, they finally got around to it. But this is the whole point. Trying to work out time back then and the rotation of the Earth and the timing and the years and the days, and it was pretty messed up and very confusing.
What is astonishing, though, is the basis of our calendar, the Julian calendar, goes back to the days of Julius Caesar, a couple of thousand years ago, and he nearly got it right. But there was this, exactly as you've said, there's this getting out of step with the seasons. And it was, I think it was 1582 when the Gregorian calendar was introduced.
Yeah, something like that.
Only in the Catholic countries, and it took a long time for the Protestant countries to adopt it. It was 1752 in the United Kingdom. So, pretty late on. I didn't know that story about Sweden. I'll need to check that out because I'm quite interested in this stuff.
Yeah, they had a February 30th. It's the only time in history because they needed to get back on track with the Julian calendar and then make the conversion sometime down the track.
Yes,
but when they made the conversion, this is another beautiful story that's worth reading. In the UK and other parts of the world, the conversion meant 11 days of the calendar had to be wiped out. So I think it became March the 1st, and the previous day was like February 15 or something.
Yeah, and it was a huge political issue. There was an election that year.
People of the time believed that the government had stolen 11 days of their lives.
Give us back our 11 days. Yeah, there were riots. That's right. Oh, dear. Well,
go look it up. It's amazing. And thanks for bringing that up, Ashley. Okay, we'll move on.
Yeah.
Slowest spinning planet.
And it is actually Venus. Which takes 243 days and 26 minutes to spin once on its axis. It might be, 26 minutes, that's right. So by far the slowest. Just the next one is Mercury, which is 58 days and 15 and a half hours. That's not the same as their day length, though, because both those planets revolve around the sun in less time than the Earth takes to revolve around the sun. So the day length and the spin length get mixed up, and it makes a mess. So we don't need to go there. But the answer to Ashley's question, it's Venus, 243 days, 26 minutes.
There you are. How long is a light year in years? Now, I think I know where he's coming from with this, but I'll throw that one back in your court, Fred.
Well, so a light year is a distance, not a time. And it turns out to be 9.5 trillion kilometers, which is very roughly 6 trillion miles. That's its length. So 6 with 12 zeros are after it. It's quite a long distance. But it's not a time. It's just the distance that light travels in 1 year. That's why time's mixed up with it.
He may have meant how long is a light year in miles. So
I think he might have done, yes.
Would have done, yes. But it's a lot of noughts.
It's a lot of noughts, that's right.
And when will people land on Mars? I was going to go there tomorrow, but I haven't got any petrol.
I'm not sure that petrol will do it, actually. It might, if you had enough of it and plenty of liquid oxygen as well. And you'll be right. Don't start your tour company quite yet, Andrew.
No.
My guess is, NASA's consistently forecast 2035 as the likely time. And of course, when you think about these things, you've got to remember that it's only every 2 years and 2 years and 2 months that the planets line up in such a way that you can make the trip. And the last time that happened was in July last year. So there's only certain periods when you can make the journey. But Elon wants to land them on Mars next year, Elon Musk. I think there's still too many problems to sort out with doing that. And I think I take NASA's forecast as being more likely. I'm exaggerating because I think Elon Musk's schedule is 2024 or something like that. I think it's at least another decade.
Yeah, most likely.
And we should. I hope your grandparents enjoyed my talk, and I think it's a great idea to have bumper stickers saying you're a space nut.
I think so too. I love it. it. Ashley, so good to hear from you. Thank you so much for sending in all those questions. I think Ashley demonstrates the enthusiasm that is astronomy, and I think it's fantastic. So thanks for getting in touch with us. Now, Fred, question without notice. Next week is episode 260. Are we going to do all questions?
Well, if we can get enough questions, I think we should. Yeah.
And that's where I'm going now because we've run out, more or less. So if you would like to ask us a question in audio or text format, go to our website, spacenutspodcast.com. Click on the AMA link or button or just the letters. It's no button or there's no tabs or anything. I don't know why we do it that way, but anyway, it works. Click on the AMA link and ask your question. If it's audio, you need a device with a microphone, basically. So there could be a smartphone or a tablet or a laptop. They have microphones built in, or anything. As long as it's got a microphone, you can say who you are, where you're from, and ask your question. Or if you want to do it the old-fashioned way via email, you can do that. Can't believe we're calling that old-fashioned now. You can do that as well because we've got a text interface on the same tab, on the AMA tab. So send us your questions. We'll try and do a bunch of them next week. If we don't get enough, that's fine. We'll find topics. I'm sure something will happen in astronomy in the next week that we can talk about. Aliens attacking the United States West Coast.
Who knows?
Yeah. Anyway, we'll sort it all out next week with episode 260. Thank you as always, Fred. It's been a great pleasure. Good to talk to you.
My pleasure too, Andrew. And good luck to the Square Kilometer Array.
Yes, indeed. Yes, the first nut and bolt will be cemented into the ground very, very soon.
Next year, yeah. See you later. Thanks a lot.
See you, Fred. Thanks a lot. Fred Watson, astronomer at large, part of the team here at the Space Nuts podcast. Hello to Hugh in the studio, who puts it all together and puts it on Facebook. And, well, no, I do that. But he does put it on YouTube and all those other platforms. Until next time, thanks for joining us here on Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.